So without further ado, we'll go ahead and talk our way through some wonderful adaptations and how the body's going to respond when we're exercising in hot environments. Now, for the lab this week, you guys will be doing the VO2 Max lab. That's going to be on YouTube. You just have to watch the video, record the numbers, and go from there. Now, when you come in on Friday, that's where we're going to go ahead and walk you through effectively figuring out the ventilatory threshold and where we think the anaerobic threshold would have been for the athlete that did that. So just make sure that you guys obviously get around to going through that at some point. And without further ado, let's talk about the joys of thermoregulation. So when I say thermoregulation, it's really just we are trying to regulate our body temperature. You've probably heard the whole average body temperature of 98.6 degrees, which, yeah, it's on average 98.6, but plus or minus literally close to 2 degrees. So you might have some folks that hang around at like a 96 degree range, and you have other folks that hang around pretty close to 100 degrees, and that's not mature fever. They just have effectively a really high metabolism, but our body's still trying to keep us within certain ranges. Now, when we are trying to exercise in the heat, that's where we're going to talk about how we're going to sweat and use evaporation to help us essentially thermoregulate, some of the risks that can occur, and then how long it's going to take us to acclimate to it, meaning we're going to get not just used to it, but our body's going to be able to do a better job of tolerating it. We're going to do the same thing when we talk about exposure to cold, limited amount of adaptation that we can have there, and then obviously some points on the different health risks that can occur. So doing physical activity is complicated by literally the temperature environments. Obviously, human beings can only exist comfortably in relatively narrow ranges of temperatures. So if we were to try to, if you think about what temperatures would you guys feel comfortable walking around in just a swimsuit? How big of a range are you guys talking? How big a range you guys would say that would be? Comfortable meaning you're not sweating, you don't feel hot, and you don't feel cold. Yeah, maybe mid 70s to mid 80s, and not even getting into humidity. Now, would you want to hang out in 50-degree weather just wearing your swimsuit and standing around? And then the opposite side of it being if it was 120 degrees, you'd be pretty warm no matter what you were wearing. And from there, we'd have issues with maybe getting ourselves into dehydration from the sweating. So we're trying to regulate our internal body temperature, and that's irregardless to what we're around. So thermoregulation, that is literally our body doing what it needs to keep ourselves around that set point. So if it's too cold, we'll start to shiver. We'll naturally try to ball up a little bit more to conserve body heat. And then the opposite is going to be true whenever it's really warm. We'll try to space ourselves out. We'll try to make, our body will be sweating more so we can use evaporation. So acclimation is going to be short-term adaptation. So this is just being around this temperature for a couple days, maybe a week or so, or 2 weeks. Acclimatization is the long-term adaptation to being in those temperatures. This is where you are physiologically different, so you can really deal with these temperatures much greater than anybody else. So a story that I share quite frequently was back when I was a strength coach at St. Louis University. I had one athlete who she was from King Salmon, Alaska. And I had another athlete on the team who he was from Phoenix, Arizona. Now, November in St. Louis is a lot like November here in Kentucky. You know, it gets to be, you know, cold, wet. It's not really, we don't really have much snow at that point in time, but it's definitely not a warm one out there. Now, they would have 5 a.m. swim practices that afterwards they would walk over to the weight room where I would train them and do dry land training. Now, to give you an idea of the distance, it would be the equivalent of walking from about probably actually Alumni Coliseum over to Moberly, maybe a little bit further than that. Now, in November, our gentleman who was from Phoenix was already wearing full sweats, a beanie, and gloves walking from there to the weight room. Meanwhile, the other athlete that I worked with, she wouldn't even bother putting her hair up or drying it and walk over in just a t-shirt and shorts for dry land, because it turns out she was very used to cold weather, and so it didn't bother her much at all, hence acclimatization. Whereas our gentleman was not used to that amount of temperature, so it was a lot harder on them. Now, a lot of you guys are from around this region, so you don't really know the far ends of the spectrum, but you guys are relatively used to humidity, which other folks, when they haven't been around that before, it can take them a little bit back when they first have to realize the brutality of trying to exercise in really humid conditions like you can obviously get in Kentucky. So remember, guys, the body's not that efficient. So when we start moving, about 75% or more of the energy that we produce is literally just wasted as heat. And that in turn heats our body up, hence why you warm up for exercise, hence why you start sweating, because you've increased your body temperature. Now, we have our heat gain. Now, that's not just from the metabolic work we're doing, but then the environmental heat. So this time of year, not much of a big factor. Maybe if you're in like direct sunlight, that's going to be radiation. Whereas conduction, that's actually physically touching a surface. So a solid to a solid. So this desk is a little bit cool, so it is conducting a little bit of heat away from my hands. And then convection is effectively a gas or a liquid blowing over you. So convection is really fast, as you guys think of like wind chill, or if you ever think about hopping in a pool of water, and most pools are usually 70 odd degrees, but when you jump inside that water initially, you're like, whoa, that's a kind of a shock to the system, because it happens to be that much cooler than your own body temperature. So when it comes to our heat between our body and the environment, it's going to be moving from the core of our body to essentially our extremities, or really just to our skin, thanks to blood circulation. So that's where we're going to be able to dissipate heat through the conduction, convection, radiation, evaporation. So when it comes to heat loss, radiation is just radiating heat to the environment. If you guys have ever seen the movie Predator, the documentary, Predator, you can see the example of thermographic imaging, though mud is not that effective at stopping it. Conduction, obviously, again, you're touching something that's cooler. Convection, that's once again, that if you think about having a fan blowing on you, and then evaporation, aka just sweating it out. Now, evaporation is going to be the one that we have the greatest amount of heat loss through. And that's going to be the one that the body tries to utilize most of its energy in trying to help you with thermoregulation. So when we're doing the mathematical equation, conduction is with actually a capital K. Once again, that's a solid and direct contact. Convection, that's going to be that gas or liquid across the surface. Radiation is going to be just infrared rays, hence why if you're outside and it's a sunny day, you can feel the sun on your skin, whether or not whether it's July or January, simply because that sun is still radiating upon you. And from there, we have what's known as our dry heat exchange, because evaporation is going to involve a loss of essentially body water coming off of you. So you can actually see an example of that radiation, because that's what you're all doing, is you're naturally radiating heat out to the environment. Now, your clothing is trapping a certain amount of that radiation and keeping it back on you. And that's exactly what your blankets are doing when you're laying in bed. Unless it's an actual heated blanket, the thing that's heating up the blankets is you. And so by being under however many blankets you have, it traps that much heat you're radiating into the environment, which in turn obviously is going to keep you warmer and hopefully a lot more comfortable. So now, evaporation is what's giving us most of that heat loss. And that's literally just this energy loss during the phase change as water goes from being a liquid to a gas. And obviously wearing clothing is going to limit this. It's going to trap this and not allow us to take as great of advantage with it. So if we take then a metabolic heat gain, and then we have all of our, in turn, plus or minuses with radiation, conduction, convection, and evaporation, we in turn are going to have ourselves a situation where in heat loss, heat balance, or heat gain. So heat gain obviously means our temperature is increasing, loss means it's decreasing. Balance means equating. Now the body's effectively trying to really keep it in balance at all times. Now you might be in a situation with heat loss and if it goes for too long. Now we're talking about legit risks of hypothermia. And then the opposite can be true. If we're talking about heat gain, now we're getting into heat exhaustion and then into heat stroke. So humidity, as everybody here probably knows, is going to massively affect heat loss. Thanks to higher levels of humidity, you're not going to get as much from evaporation, whereas with lower levels of humidity, you get a greater amount of evaporation. So like anything else, when it gets to be those really humid days where you just walk outside and you immediately feel damp, it turns out evaporation doesn't help you out that much. That's where at the end of the workout, you're wearing a t-shirt that weighs 2 or 3 more pounds because the water's just stuck to you. It never really had a chance to evaporate off and help cool you down. Now, obviously that fluid that we're sweating off is coming from somewhere in the body. And a lot of it is coming from your plasma of your blood, the water fraction, which in turn is causing hemoconcentration, which gives us that cardiovascular drift, makes it harder for the heart. The heart has to work harder, has to pump more beats per minute because stroke volume is going down, which in turn is making things feel more and more difficult. And so on the right, you can see how we have this interaction of all these different components that are going to be causing us to both gain and lose heat. Now, a certain amount of sweat in turn is going to help us lose a certain amount of energy. And like anything else, it's going to scale. So you can lose that much energy through sweat. The key is if you need to keep losing more energy through sweat, you're gonna have to find that fluid from somewhere. So hence why rehydration. And remember the Titans was incredibly wrong because water does not in fact make you weak. Water is what in fact keeps you alive. So, yay. So if we literally have unlimited amounts of convection and evaporation, you in turn can literally hang out in a room that was 400 degrees. Now, would you want to do that? No, but that is something where you can actually, you can tolerate it. Just like you can also tolerate your temperature being too high or too low for brief periods of time. Now, for the most part, our body wants to keep us around that 37 degrees or that 98.6 if we're talking Fahrenheit. Once we go above 40 degrees centigrade or with our body temperature, it literally is going to start to shut down physiological function. Specifically, we're no longer going to get that effects from the preoptic anterior hypothalamus, which in turn is going to be thermoregulating. That's why when heat stroke sets in, you stop sweating. And then you're literally getting in a situation where if your temperature goes high enough, you start to bake your brain and all the other proteins in your body, which in turn is not good for health. So, just like we've spoken about before, negative feedback is the major way that our body is going to do its best to try to control our body temperature. So if the body is going to detect from both the blood and internal temperature increases, which is going to then relay that information onto the hypothalamus, which is going to then, through our sympathetic nervous system, tell our body to have greater amount of vasodilation to the skin. So we're going to send more blood flow to it and increasing sweat production, which combined hopefully will bring that temperature down. Now, on the other side of it, when our temperature gets to be too low, we are going to vasoconstrict to the skin. We're going to send less blood flow there, and we are going to cause the muscles to start contracting involuntarily because that in turn is going to be producing work, and 75% of that or more is going to be wasted as heat energy, which in turn is going to help us increase that body temperature. Like anything else, we go too far to one end of the spectrum or the other, it literally starts to shut down. In fact, people, when they go too hypothermic, there's examples of people, unfortunately, that have passed hypothermia that were found effectively in their underwear. Because at a certain point, your body literally shuts down its ability to feel cold. And when this occurs, it's paradoxical insulation or something along those lines, where they don't feel cold anymore, so they just disrobe, because like, why wear all these ski pants and everything else if you don't feel cold anymore? And unfortunately, that tends to be the end of the ballgame. So aside from your wonderful thermoreceptors in your skin, you then have them inside of your brain and your spinal cord, and that's really what's going to be sending the much greater signal that something needs to be done. So that vasoconstriction is going to the skin is going to cause less heat loss. Vasodilation is going to cause greater heat loss. So as you'd expect, it's going to come down to what's the major overarching goal? Do we need to dissipate more heat or do we need to retain more heat? And our total amount of sweating that we're going to go through is going to come down to, once again, that signaling that we're going to get because our body temperature is too high. So we can use evaporation. And what's interesting is this is going to improve in function with time. So I'm sure every single person here has found themselves to be shivering before. It is an actual real situation where you're going to cause your muscles to contract in ways that doesn't actually help you perform work, but just causes you to shake, which in turn is wasting energy, but releasing energy itself, which in turn is going to be heating up those tissues. And when it comes to overall exposure, if you really want to try to lose more weight, you should actually expose yourself to more cold temperatures because that in turn is going to increase your metabolism because we're trying to increase heat production. Specifically, you're going to see increases in your thyroid hormone and your epinephrine, norepinephrine as a means to help increase your body temperature. Now, as you guys would suspect, if you're too cold, you're gonna have a heck of a time ever trying to relax or sleep, but this is more of, once again, short-term as opposed to long-term strategies. So what's going to happen when you start exercising in heat? Well, it turns out we're going to increase our metabolic heat load, which in turn is going to throw off our thermal homeostasis in most environments. It's pretty rare you're going to exercise in a place that's cool enough that you're never going to really have to sweat if you're really moving, and you're also not going to be that cold. So what's going on? Well, thanks to that vasodilation to the skin, you are going to be able to use more convection for heat loss, but it's going to require more blood flow. And remember, we've only got a finite amount of cardiac output. So we're going to find that we're going to, through the wonders of epinephrine, increase that heart contractility and get more vasoconstriction to all the areas of the body like the digestive tract that aren't as necessary, obviously, when we happen to be exercising. Now, over a long enough period of time, we are going to have a decrease in blood volume thanks to sweating, which in turn is going to cause our stroke volume to slightly decrease, which is going to then, in order to keep the same cardiac output, cause our heart rate to increase. So it's going to literally start to lead to fatigue, and also where you're going to start to effectively feel a lot more tired. Now, I know a couple of you guys have done that fire gear study that we're currently doing. Seeing if anybody is in here today. Yep, yeah, so we got Tyler and Trendon. So gentlemen, if you do remember, about how much higher would your heart rate be on the second half of that load carriage, especially when you're wearing the fire gear, compared to how it was on the first half?
The heart rate's a lot higher.
Yeah, and that comes down to, because how much do you think you're sweating inside of that gear? Fair enough, Tyler, I like it. So really, guys, remember, we've got a finite amount of output. So when it comes to that cardiac output, if we're really trying to do maximal exercise, we're trying to send all that blood flow to our muscle and as little as possible to skin, which in turn is going to limit how much exercise or how high of an intensity we're gonna be able to work with, or increase our risk of overheating, because the body is going to prioritize exercise output over avoiding overheating, because it's more important to avoid becoming something's dinner than it is to risk heat illness, if that makes any sense. Not a good long-term strategy, because it's pretty rare that you're in those situations, but that's how the body's wired. So, and it's even bigger of an issue in people that are untrained. So for the most part, once you get over a certain temperature, the body tends to just shut down physical exercise. You're gonna have issues with blacking out or just being dizzy and a lot of other issues. But that doesn't necessarily mean it's gonna kick in time to help certain people. Now, notice, guys, all of our graphs on the right, and you can see how when you're exercising at different temperatures, specifically exercising in a 78-degree room as opposed to a 110-degree room, how much longer you're going to be able to go, and look at how much higher the heart rate is going to be in that condition. Now, another fun fact of science, and I don't know if I'd necessarily call it fun, but it's important to just understand how science works. Notice, guys, the upper left figure. What is the way that they're measuring the temperature? Yes, Ian. So you guys can take a wild guess of where you got to put that probe. Indeed. Do you guys want a gross but slightly entertaining story? Oh, it gets better, Zach. All right. So I'm going to pause it so you guys can enjoy, or pause the recording. So that way you guys can enjoy the story, and the kids that didn't make it, they don't get to hear it. And now back to the show. So as you'd expect, guys, the warmer it is, the more you're going to sweat, because it turns out evaporation, especially when we're in a hot environment where it's like a warm breeze is over us, we're on a warm surface and the sun's out, the only way we're going to be able to lose energy is through evaporation. And so we are going to literally start to produce more and more sweat. Now, our electrolyte content is going to be less than what we find in the plasma. It's going to reabsorb some of the salt, sodium and chloride. And when we go to heavy sweating, now we're talking about it's not going to be as dilute. So now we're losing even more sodium and also chloride. So hence why when we talk about electrolytes, and also you have some magnesium losses, some potassium losses, and even zinc and calcium and a couple other minerals can be sweat out. So now, obviously, training is going to help improve this, in that we are going to do a better job of resorbing both our sodium and our chloride. Now, not so much with that potassium, calcium, and magnesium. Hence why no matter what, if we're exercising, we've got to make sure we're replenishing all of our minerals, but we're not going to be as big of an issue. Now, the total amount that you can actually sweat out during exercise is going to vary based upon body size. And obviously, greater amounts of sweating is going to cause greater losses of blood volume, which in turn is going to negatively affect our cardiac output. And as we become more and more dehydrated, now we literally risk issues with injury. So if you guys look at the table on the bottom, we can actually see how the body is going to adapt to exercising under different types of trained status. And that specifically, as we become more and more well-trained, you are going to do a better job of losing less sodium and potassium, irregardless of gender. But notice in general, and this is off of older research, that in this example, women were actually having greater losses of your electrolytes as opposed to males. So when we're going through all this fluid loss, we're going to stimulate both our adrenal cortex and our posterior pituitary gland, which in turn is going to tell our body to hold on to more water, specifically by making sure that we have less loss, thanks to aldosterone and antidiuretic hormone, ADH. So aldosterone is going to tell our kidneys to hold on to more sodium, and then antidiuretic hormone, which in turn is going to be influencing with some vasopressin, is going to tell our kidneys to retain more water. And that's why I'm sure some of you guys have been outside exercising in the heat for an entire day, and or just working out in the heat and been like, I have not had a pee yet today. Like, you have that moment of like, oh boy, I am probably dehydrated and should do something about that. So when we have somebody exercising in the heat, well, we have to really look at effectively the 6 major risk factors, which is how much metabolic heat production we're going to do. If you're just out there playing golf in the heat, it's highly unlikely that you're going to have any issue with overheating. Now, if you're going to go out there and you're going to try to run a 5K, 10K marathon, play soccer, play baseball, especially if you're a catcher, a lot of other types of sports, we're going to have some issues. Obviously, how hot is it outside? So if it's 50 degrees outside, we don't really need to worry whatsoever about how hard you're exercising when it comes to heat illness or heat injury. Instead, we just got to make sure, if anything, you just appropriately hydrated. Now, what happens to be the total amount of humidity in the air, since obviously that's going to negatively influence how much of an evaporation effect you're going to have, the higher it is. How fast is the wind blowing? Are you going to be in direct sun? Are you going to be in the shade or otherwise? And then obviously, what type of clothing are you wearing? So, like anything else, all of these are going to be influencing heat stress, and we just want to try to keep them all into account and do the best that we can. Now, when it comes to clothing, what would be some examples of sports when you're playing them, you really don't have any option but to be wearing essentially equipment that's counter effective for thermoregulation, but is obviously important for athlete safety. Bingo. Football equipment is a great one. What other sports? Yeah, baseball equipment in general, same thing with softball equipment, and then catcher's gear. Absolutely. Good. You guys think of anything else? Yeah, lacrosse gear. So same thing, personal protective equipment that they're going to have, specifically the male version of lacrosse. Most other sports, you can at least try to dress down enough to make it a little bit more comfortable, uh, yeah, thermically for you. But at the same time, you're going to have certain sports where effectively it could potentially be on the other end, but that's relatively rare. So people that are trying to run like long distances in very cold weather, that might be an issue, but that's not with heat stress. Instead, that's more cold stress. So when it comes to how we're going to measure this, you can have the heat index, which is, it's kind of useful, but what's more important is going to be what someone's wet bulb globe temperature. So what you're doing is you're looking at a couple different components. So you're looking at effectively what's the temperature when you can take advantage for the wet bulb, where it's going to see the effects of evaporation, conduction, and radiation. The dry bulb, which is just straight up air temperature. And then notice the globe thermometer where it's set inside of a large globe that in turn is going to be retaining a lot more radiation heat. So when you use all of these together, it in turn is going to give you a better idea of effectively what that temperature is going to literally be like for the athlete. So if it goes too high or we're having to be exercising in such a high intensity for too long in warm environments, we're going to run ourselves into situations where we're getting heat illness. Now, the first and lightest form of this is what's known as heat cramps. Now, this is going to be where you're going to have cramping of the large muscles, mostly due to issues with losses of sodium and some of the other electrolytes and dehydration. Now, this is going to happen in people that are heavy sweaters, and we can help avoid this by taking in not just more fluids, but making sure that we have electrolytes in the things that we happen to be drinking. Now, I'm sure a number of you guys have had this before or seen this happen to a teammate of yours. And when we talk about people that are heavy sweaters, you guys have probably worked out with somebody before where it's like they had to change their t-shirt midway through a workout because it just looked like they had taken a shower. And some of us do have a greater potential for sweating, which is good because it literally means you're better at thermoregulating. However, it is going to be an issue with making sure that you're staying adequately hydrated if you happen to be sweating that out all the time. Now, the next case, this one is heat exhaustion. This is where people are going to be fatigued, they're going to be dizzy, they're going to start feeling nauseous, they might even vomit from it, faint. and sometimes present with a weak and rapid pulse. Now, this is caused by severe dehydration thanks to sweating. And so because of the competition between blood flow to the muscle and the skin, you're going to have issues with literally poor cognitive function and just neurological function. Now, this is where we're starting to get overwhelmed. So if we're not careful at this point, now we're getting ourselves into heat stroke. How many of you guys have ever gotten into or felt heat exhaustion before? What were you doing, Catherine, when that happened? Yeah, that makes sense. Tyler, what were you doing when that happened? Yep. The one time that this definitely hit me was whenever I was working as a stonemason over the summer between in my undergrad, doing that for work, and yeah, yeah, I had to sit down so I didn't fall down, and it took me a while. Um, yeah, thankfully my coworker was able to pick up the slack, and then it's kind of funny is I ended up picking up the slack for his little brother the next summer when I was working as a mason. So small world. Now, heat stroke itself, that's where we're legitimately risking death. Oh, that sounds about right, Ian. And that sounds definitely like a possibility there, Raquan, with having to do that much of a shuttle. Now, are you guys familiar with what happened to the band? I think it was 2 years ago, marching band here. So I believe it was November or October. It was one of the later home football games that, the band, they wear those, the big costumes that are obviously very warm. And it was an unseasonably warm day that day. And they were obviously had the football game in the middle of the day. And I believe they had, it was something absurd. It was like over 10 of the members of the band went down with heat exhaustion and borderline getting into heat stroke. They had to IV a number of them because they were having so many issues. So yeah, that's an issue you can even have with obviously individuals that you don't think of as your conventional athletes, thanks to being exposed to obviously too high of temperatures. And you can't really thermoregulate very well when you're wearing a full band uniform. So heat stroke is obviously going to be the point of which where, yeah, we can literally risk death. Our POHA or POAH, sorry, is no longer working like it should. Our core temperature should be over 40 degrees. We're going to be confused, disoriented, and possibly even passing out. If nothing's done and they're not removed from the hot environment and preferably cool down rapidly, you can literally risk death of those individuals. And so when you're looking at the increasing severity, you can see how there's like a little bit of overlap of where you're going to move from one to the other. But the big key is like once you stop sweating, you're in a lot of trouble. And it's a weird thing to ever notice that you stop sweating. But like anything else, that's why it's that ounce prevention. Making sure you're doing regular hydration breaks, making sure you're giving your athletes time to acclimate to the heat, and you're staying up and aware of any potential essentially symptomology that they might be starting to present with. So if it's going to be over 28 degrees centigrade through that wet bulb globe thermometer or through temperature, you're not outside. We're going to try to practice obviously away from the hottest parts of the day. And we're never going to be restricting our fluid intake. That's just dumb. We want to make sure that they can drink as much as they'd like to, trying to take breaks so they can take smaller drinks every 15 minutes to at least, or at most a half hour, and trying to make sure that you're controlling for that temperature. Now, obviously, with the clothing side, trying to minimize as much as you can comfortably, so that way your athletes are going to be able to perform and have a lower risk of overheating. So you can obviously see in just a running example, when individuals are given fluids and not given fluids, you can see that increasing body temperature is going to keep occurring unless they have access to fluids. So The basic guidelines for practicing and competing in that heat is going to be that you should not be out there in those temperatures over 28 degrees centigrade. You want to make sure that you've got fluids that they'll drink. So the key is if you got things that are really hypertonics, like really sweet beverages and otherwise, can be really hard to take down. Anyone that's thirsty enough will drink hot water, but it's pretty uncomfortable. So a cool beverage is going to be a better choice there. And you want to try to make sure that your fluid intake is based upon your losses. So you're essentially doing 1 liter of water in for every 1 kilogram water loss, since water has a density of about 1, so it's 1-1 ratio. And you could say the same thing if you lose a pound, you got to drink a pound of water, aka 16 fluid ounces. So making sure that you're obviously aware of what are going to be the different symptoms of heat illness. And like anything else, if you're the one in charge, take charge. Don't be dumb. Make sure that you're doing your best to keep in mind the health of the people that are participating in whatever you happen to have them either practicing in or competing in. So you do acclimate to heat. And what you're going to find is the more frequently you're exposed to heat, you're going to start to see these changes and you're going to allow for better performance in hot conditions. Now, the acclimation, so short-term adaptation, is going to take usually about 10 days. So say about 9 to 14. And you're going to see the body do its best to essentially deal with those temperatures. Now, acclimatization, where you're literally just used to this temperature and it's just kind of another part of your day, that's long-term. So we're talking about months, if not years. Hence the example of those 2 swimmers I worked with at SLU, where they were obviously very acclimatized to growing up in the desert of Phoenix, Arizona, or the getting close to the tundra of northern Alaska. Now, when we acclimate, our cardiovascular system is going to be optimized, meaning we're going to do a better job of keeping up that cardiac output, not having as many issues with cardiovascular drift. We're going to increase our sweat rate. We're going to do a better job of sweating everywhere so that we're going to be able to thermoregulate, and our sweat content is going to become more dilute, meaning you are going to actually go ahead and not lose as much of that sodium and chloride like we talked about earlier. This in turn is going to lower your core temperature. Now, another thing is not only are you going to sweat more, but you're going to sweat earlier. So meaning when you first start to exercise, you're going to find your sweat rate is going to jack up pretty quickly, which is a good thing because now you're going to be able to thermoregulate much more easily and much more rapidly than someone that takes longer. So if anyone ever makes fun of you for sweating really quickly or really easily, that's the equivalent of making fun of somebody for being too in shape, too rich, too pretty, too smart. It doesn't really happen. And if it does to you, good on you. Good on you. I'm jealous. So initially, you're going to see an increase in that plasma volume. So thanks to increasing some of the proteins and electrolyte content of the blood, you're going to be able to pull more fluid into. So yes, you have a little bit of hemodilution, but you're going to have a greater amount of volume that you can sweat from. You're going to find then your overall heart rate is going to go down, even though we're going to maintain that higher cardiac output that we need to, or we're going to be able to increase it because our stroke volume is going to be do a better job of staying where it needs to be. And yes, you're going to sweat earlier, sweat more, and sweat more dilute. So you can see how the sweat rate is going to increase with time being exposed to heat. Your final temperature is going to go down and your final heart rate is going to go down because you happen to be more acclimated to what's going on. You can see how both that rectal temperature is lower and so is going to be the exercising heart rate during longer durations, thanks to your body literally doing a better job. And this is literally in only about 10 days. So the way you want to acclimate an athlete is if you go to a hotter environment, you want to go ahead and spend a couple days out in the heat, just walking around, low intensity, not even exercising, and then slowly build up your exercise intensity while they're still being exposed to the heat. So you can travel anywhere. In fact, just a quick poll question, so yes or no, do you guys think that half of the population in Kentucky during the summer are actually acclimated to the summer heat? Do you guys think that half the population is actually acclimated to the heat during the summer? Good. hit the polling question part of it, Catherine, though I appreciate you obviously putting no in the chat. All right, we have a lot of people that are saying no. Why? Why do we think that most people are not actually acclimated to the summer temperature? Exactly, Ian and Haley. Most people go from an air-conditioned home to an air-conditioned vehicle to an air-conditioned job and try to spend as little time as possible outside. So you might have an athlete that's out there in Phoenix, but they're never actually experiencing the heat of being outside in Phoenix. And the same thing can be said about being in a colder climate where they just go from being inside of a nice heated house to a nice heated vehicle to a nice heated gym. So they never really have to experience the cold. So it's important that you understand that we're getting those athletes out there. Now, my question for you guys is what would you guys try and do to try to mimic being in the heat? So say you had to train, right now, okay, the world's back to normal. You can travel places again, okay? And you have to compete in some place in, we'll say, the Southern Hemisphere, AKA, so like when it's winter here, it's summer there. So you have to go from training here and go compete in Australia in January, AKA their summer, one of their hottest months on the year. What would you try and do to help get your athlete to acclimate? What would you do to have them try and get used to being out in the heat? And, well, actually, John, your point on the elderly avoiding the heat, it's interesting in that thermic stress and cold stress is actually a useful stress for the body. You do want to go through being cold on occasion, being hot on occasion. It's a hermetic stressor, so it actually does cause positive reactions in the body, specifically when we're going to talk about, we can trick some things with cardiovascular drift, along with you'll see some interesting adaptations that occur thanks to both heat shock and cold shock proteins. But I'm going to go ahead and throw you guys in. Oh, I'm not going to throw you guys in groups. We've got 3 minutes left and that's too brief. So go ahead and take some wild shots. What would you guys want to do to try to get somebody used to being in hot weather, even though there is no hot weather outside? Absolutely. Absolutely, Tyler. Try to have them exercise in a hotter gym, and maybe not as an exercise in a sauna, but definitely going through sauna exposure. Good, good. What else? Yes, layers of clothing. So having them exercise in heavy layers of sweats, even when they're inside a gym and it's obviously not that cold. So they're at least going to get some semblance of the type of stress they're going to get from being out in warmer temperatures. Absolutely. Nice job, guys. Nice job. Now, while we're touching on the topic of the sauna use, there is some interesting research about using saunas to actually help activate those heat shock proteins. So having someone be exposed to about 20 minutes, it seems, of a very hot sauna after training seems to actually enhance all markers or a lot of markers of performance and recovery, especially with aerobic athletes. And the nice thing is about being in a sauna, thanks to that cardiovascular drift and the great amount of blood flow to the skin, if you literally just sit in a sauna long enough and you wear a heart rate monitor, it's going to look like you're doing cardio, even though all you're doing is sitting still, because your heart rate is going to be going up and your body's going to have to be doing more work trying to thermoregulate. So effectively, it's a good way to do and have some positive cardioprotective effects without actually having to go out there and do a lot of running or other types of impact work. So questions, comments, concerns, and we're going to start off here talking about exercising in the cold on Wednesday. Questions, comments, concerns, anything for the good of the order? All right, guys. Well, you know what you need to do with your lab. Make sure you go on, you watch the video on YouTube, you copy down the numbers, and make sure you're doing your best to write down all of those. And then we're going to talk about, you can try to figure out the ventilatory threshold and the anaerobic threshold on your own. If not, that's okay. That's what we're going to be talking about whenever we come and meet together on Friday for lab. So take care of yourselves, guys. Be safe out there, and I will see you guys on Wednesday. All right, guys. No questions, comments, concerns. Then I guess that's it for the day. Bye-bye.